So for this difference equation, so first, what is difference equation? So a difference equation is a relationship between the differences of an unknown function, and we are solving these difference equations by using Z transform. So let us solve examples. So already we have discussed. So this is a revision class. So directly we'll start this discussing examples on difference equation. So first example, solve the difference equation u suffix n plus 2 plus 6 u suffix n plus 1 plus 9 u suffix n is equal to 2 raised to n. So difference equation is given with u naught u1 is equal to 0, conditions given u naught and u1 both equal to 0. You need to solve this difference equation by using Z transform, right? So very first step is taking Z transform on both sides of this difference equation. So this will be the first step, taking Z transform on both sides of this equation. So Z transform of u suffix n plus 2 plus 6 Z transform of u suffix n plus 1 plus 9 Z transform of un. This is equal to Z transform of 2 raised to n, right? So we know what is Z transform of u suffix n plus 2. So you substitute that, and we know what is Z transform of u suffix n plus 1, right? So Z transform of u suffix n plus 2 is Z square u of z minus u naught minus u1 of z plus 6 into Z transform of u suffix n plus 1 is z into u of z minus u naught plus 9 Z transform of un is u of z. This is equal to z divided by z minus 2. Z transform of 2 raised to n. It is like Z transform of a raised to n. Z transform of a raised to n is z divided by z minus a. So in place of a, we have a 2. Now conditions are given. What are the conditions here? u naught and u1 both equal to 0. Now apply the conditions for this one, right? So u naught 0, u1 0, and here u naught 0, right? Now rest things, see here, u z square u of z, 6z u of z, 9 u of z, means what is common here? U of z is common. So collect the coefficients of u of z. So here u of z is there, coefficient of this is z square, and plus 6z is there, and coefficient of this u of z is plus 6z, right? And coefficients of this u of z is 9. So we have z square plus 6z plus 9. U of z is equal to z divided by z minus 2. Why we got this? We have applied the conditions. So what are the conditions here? U naught and u1 both equal to 0, right? Next we want u of z. So u of z is equal to, you transfer this z square plus 6z plus 9 from LHS to RHS. So this is in numerator, comes this side, denominator, z divided by z minus 2, z square plus 6z plus 9, right? Next we want u of z divided by z. Take this z to this side. So u of z divided by z, this is equal to 1 divided by, and this z minus 2 is as it is, z square plus 6z plus 9. So this is nothing but perfect z plus 3 raised to 2. Z plus 3 raised to 2 means you expand this, z square plus 6z plus 9, you will get, right? It is like a plus b whole square. A is z and b is 3. So this is nothing but z plus 3 raised to 2, right? Now we have a standard result of what here? Z transform of inverse Z transform of Z divided by Z minus A, like this, right? So we have Z minus 2, Z plus 3 raised to 2 in the denominator, right? So first you resolve this by using partial fraction. So consider this one, consider 1 upon Z minus 2, Z plus 3 raised to 2. This is equal to a divided by z minus 2 plus b divided by z plus 3 plus c divided by z plus 3 raised to 2, right? Now take LCM, right? Take LCM, 1 upon z minus 2, z plus 3 raised to 2. This is as it is. This is equal to, take LCM. So we have z minus 2. So multiply z plus 3 raised to 2 2 to a plus, and here z plus 3 is there, multiply z minus 2 and z plus 3, because LCM will be z minus 2, z plus 3, z plus 3 raised to 2, or z minus 2, z plus 3 raised to 2. So we have only one z plus 3. So multiply z minus 2 and z plus 3. And here z plus 3 is there, multiply z minus 2. So you will get here as a into z plus 3 raised to 2 plus b into z minus 2 z plus 3 plus c into z minus 2 whole divided by z minus 2 z plus 3 raised to 2. Right? Now, by proper substitution of this z, we need to find a, b, c values. So put z is equal to 2. Wherever z is there, no, in this you substitute 2. Right? So we'll get here as 1. This equal to, so substituting z is equal to 2. So 2 minus 2 is 0. So this term is 0. And here 2 minus 2 is 0. This term is 0. Means these two are 0. And here you substitute 2. 2 plus 3. 2 plus 3 is 5. 5 square is 25. Means 1 is equal to a into 25 plus 0 plus 0. We want a. Take this 25 to this side. So a is equal to 1 by 25. So this is in numerator, comes this side denominator. So a is equal to 1 divided by 25. Right? Now we need to find these two, a and b. Now substitute z is equal to minus 3. Z is equal to minus 3. So what we'll get, see here. So 1 is equal to, substituting minus 3 here, minus 3 plus 3 both get cancelled. So this will be 0. And here minus 3 plus 3, so get cancels. So this is 0. Plus c into, in place of z substitute minus 3 minus 2 is minus 5. So we want c is equal to minus 1 by 5. So take this minus 5 from RHS to LHS. This is in numerator, comes this side denominator. Next, last will be, we need to find here b value. Right? So equate the coefficients of z square both sides. Right? So LHS, we don't have z square term, so z square is 0. In RHS, so you expand this, definitely we will get a z square term, and coefficient of this z square is a. Coefficient of this z square is a plus, right? And here you multiplying these two, so you'll get z square term. So coefficient of this z square will be b. So a plus b, and here we don't have z square term, so this is 0. So equating the coefficients of this z square both sides, so we will get here as 0 is equal to a plus b. We want a, so a is equal to minus, we want b, so b is equal to minus a, so b is equal to minus, a is 1 divided by 25. Now we have a is equal to 1 divided by 25, b is equal to minus 1 divided by 25, and c is equal to minus 1 by 5. Right? Hence 1 upon z minus 2 z plus 3 raised to 2, this is equal to, a is 1 divided by 25, 1 upon z minus 2, and b is minus 1 upon 25, 1 upon z plus 3, and c is minus 1 by 5, 1 upon z plus 3 raised to 2. Right? So this is 1 upon z minus 2 z plus 3 raised to 2. Now hence we got u of z divided by z is equal to 1 by 25, 1 upon z minus 2 minus 1 upon 25, 1 upon z plus 3 minus 1 upon 5, 1 upon z plus 3 raised to 2. We want u of z. So u of z is equal to 1 upon 25. Take this z. So this is in denominator, comes this side numerator. So each term multiply z. Each term multiply z. So you'll get here as z divided by z minus 2. 1 upon 25 z divided by z minus 2 minus 1 upon 25 z divided by z plus 3 minus 1 by 5 z divided by z plus 3 raised to 2. Now take inverse z transform on both sides. So z inverse of u of z, this is equal to 1 upon 25 z inverse of z divided by z minus 2 minus 1 upon 25 z inverse of z divided by z plus 3 minus 1 by 5 z inverse of z divided by z plus 3 raised to 2, right? So we have a standard result. Z divided by z minus a is a raised to n. Inverse z transform of z divided by z minus a is a raised to n. No problem for this. And inverse z transform of z divided by z plus a is minus a raised to n. So this is also no problem. Only thing is we need to find z inverse of z divided by z plus 3 raised to 2, right? So un is equal to 1 divided by 25, 2 raised to n, because a is replaced by 2, minus 1 divided by 25, z inverse of z divided by z minus of minus 3, a is minus 3, or else z inverse of z divided by z plus a is minus a raised to n. Both are same, right? Minus 1 by 5 z inverse of, so here we have z plus 3 raised to 2. So denominator make it z minus a, z minus a. So writing this plus as minus of minus 3, right? So z minus of minus 3 raised to 2. So this is over. And numerator I need az. I need az. A is minus 3. I need az. We have only z term. Multiply minus 3 and divide minus 3. Because we have a standard result. Z inverse of az divided by z minus a raised to 2 is n into a raised to n. N into a raised to n. So we have only z term. So multiply a. So we want a term. So we have multiplied. Whatever we have multiplied, we have to divide to balance the equation. So here minus 3. So a term I want. So a is minus 3. So this term I want in the numerator. So I multiplied minus 3. So whatever I have multiplied, I will divide. So this is minus 3, right? Now 1 upon 25, 2 raised to n, minus 1 upon 25, minus 3 raised to n. And this minus is plus, 5 into 3 is 15, 1 upon 15, n into a is minus 3 raised to n. So this will be the required answer. So these three results we have used. Standard results. Z inverse of z divided by z minus a is a raised to n. Z inverse of z divided by z plus a is minus a raised to n. Z inverse of az divided by z minus a raised to 2 is n a raised to n. So these three results we have used, right? So now move on to next example, right? By using z transform, solve u suffix n plus 2 plus 4 u suffix n plus 1 plus 3 u suffix n is equal to 3 raised to n, given that u0 is equal to 0, u1 is equal to 1. So conditions are given, u0 is 0, u1 is 1, right? So we have a difference equation. So very first step is take z inverse, take z transform on both sides, right? Two difference equation, right? Solution of this. So taking z transform on both sides of this equation. So z transform of u suffix n plus 2 plus 4 z transform of u suffix n plus 1 plus 3 z transform of un is equal to z transform of 3 raised to n. We know what is z transform of a raised to n. So z transform of a raised to n is z divided by z minus a. So in place of a we have a 3. So here right hand side will be z divided by z minus 3, right? Now we know that what is z transform of u suffix n plus 1 and u suffix n plus 2. So we know that. So that you substitute. So this will be z transform of u suffix n plus 2 is z square u of z minus u0 minus u1 of z plus this 4 is as it is, z transform of u suffix n plus 1 is z into u of z minus u0 plus 3 u of z. This is equal to z divided by z minus 3. Now use the condition. So what are the conditions here? u0 is 0, u1 is 1. So first collect the coefficients of u of z one side. So coefficients of u of z will be first term. So for this one we have u of z term. So coefficient of this is z square plus 4 coefficient of this u of z is z, so plus 4z, and coefficient of this u of z is 3. So z square plus u of z plus 3 u of z, right? So apply the conditions u0 0 and u1 is 1. u1 is 1. So 1 by z into z square. 1 by z into z square. So 1 z get cancels. You'll get this as minus z. You'll get this as minus z because negative sign is there. So next step will be z square plus 4z plus 3 u of z minus z square divided by z. u1 is 1 and multiplied by z square will be z square by z. Z cancels. So z square plus 4z plus 3 u of z is equal to z divided by z minus 3. So minus z you take from LHS to RHS, so this becomes plus z, right? So u of z, this is equal to z divided by, so take this z square plus 4z plus 3 from left hand side to right hand side. This is in numerator, comes this side denominator. Z divided by z minus 3, z square plus 4z plus 3 plus z divided by z square plus 4z plus 3, right? Next we want u of z divided by z. So u of z divided by z is equal to 1 upon z minus 3. So z square plus 4z plus 3. So find the factors for this. Z plus 3, z plus 1. So you'll get here as 1 upon z minus 3, z plus 3, z minus 1 plus 1 upon z plus 3, z plus 1. Take this as equation 1. We have to resolve these two by using partial fractions. So consider first one, 1 upon z minus 3, z plus 3, z plus 1. So all factors are different. So we can write this as a divided by z minus 3 plus b divided by z plus 3 plus c divided by z plus 1. Now take LCM and simplify the denominator both sides. So we'll get here as 1 is equal to, here z minus 3 is there, multiply z plus 3, z plus 1, and z plus 3 is there, multiply z minus 3, z plus 1, and z plus 1 is there, multiply z minus 3, z plus 3, right? So 1 is equal to a into z plus 3, z plus 1 plus b into z minus 3, z plus 1 plus c into z minus 3, z plus 3. Now put z is equal to 3. So in this equation, substitute z is equal to 3. So z is equal to 3 means here this term will be 0, 3 minus 3, and this term is also 0. So substitute 3, 3 plus 3 is 6, and 3 plus 1 is 4. So you'll get here as 1 is equal to 6, a into 6. 3 plus 3 is 6, and 3 plus 1 is 4. Means a is equal to 1 by 24. A is equal to 1 by 24. So substituting z is equal to 3. So you'll get a is equal to 1 by 24. Now put z is equal to minus 3. So substituting z is equal to minus 3. So these two terms will be 0. So you'll get here as 1 is equal to 0 plus substituting z as a minus 3. Minus 3 minus 3 minus 6. Minus 3 plus 2 is plus minus 3 plus 1 is minus 2, right? And c is 0. So we'll get here as b is equal to minus into minus is plus, 6 into 2 is 12. So b is equal to 1 upon 12. Now put z is equal to minus 1. So 1 is equal to a, 1 is equal to 1 is equal to, so substituting z is equal to minus 1, this term is 0, this term is 0. C into minus 1 minus 3 is minus 4, minus 1 plus 3 is 2. 4 into 2 is 8 with negative sign. So C is equal to minus 1 by 8. So substitute here. So you'll get 1 upon z minus 3, z plus 3, z plus 1. This is equal to 1 upon 24, 1 upon z, 1 upon z minus 3 plus 1 by 12, 1 upon z plus 3 minus 1 by 8, 1 upon z plus 1. Right. Now consider second one, 1 upon z plus 1, z plus 3. So using partial fractions, So we'll get here as taking LCM and simplifying the denominator. So 1 is equal to A into Z plus 1 is there, multiply Z plus 3, plus B into Z plus 3 is there, multiply Z plus 1. So by proper substitution of Z, find A and B. Put Z is equal to minus 3. So we'll get here B as minus 1 by 2. And Z is equal to minus 1. You will get A as 1 by 2. Hence 1 upon Z plus 1. Z 1 upon Z plus 1 Z plus 3. This is equal to 1 by 2 1 upon Z plus 1 and minus 1 by 2 1 upon Z plus 3, right? Hence u of Z divided by Z is equal to 1 by 24 1 upon Z minus 3 plus 1 upon 12 1 upon Z plus 3 minus 1 by 8 1 upon Z plus 1 plus 1 by 2 1 upon Z plus 1 minus 1 by 2 1 upon Z plus 3. Now u of Z is equal to multiply Z term. So this is in denominator, comes this side numerator. So multiply Z to all the terms. So you'll get here as 1 upon 24 Z divided by Z minus 3 plus 1 by 12 Z divided by Z plus 3 minus 1 by 8 Z divided by Z plus 1 plus 1 by 2 Z divided by Z plus 1 minus 1 by 2 Z divided by Z plus 3. So next step will be you take Z inverse Z transform on both sides. So Z inverse of u of Z is equal to 1 by 24 Z inverse of Z divided by Z minus 3 plus 1 by 12 Z inverse of Z divided by Z plus 3 minus 1 by 8 Z inverse of Z divided by Z plus 1 plus 1 by 2 Z inverse of Z divided by Z plus 1 minus 1 by 2 Z inverse of Z divided by Z plus 3. So u of Z is equal to 1 by 24. Z inverse of Z divided by Z minus 3 is, in place of A we have a 3 raised to n plus 1 by 12. Z inverse of Z divided by Z plus 3 will be, in place of A what we have here 3. So minus 3 raised to n, minus 3 raised to n minus 1 by 8 and Z divided by Z plus 1 is there. In place of A we have 1. So minus 1 raised to n plus 1 by 2. And here also in place of A we have 1. So minus 1 raised to n minus 1 by 2. In place of A 3. So minus 3 raised to n. So we have 1 upon 24 3 raised to n minus 5 by 12 minus 3 raised to n plus 3 by 8 minus 1 raised to n. So here we have used these two results. Z inverse of Z divided by Z plus A is equal to minus A raised to n. Z inverse of Z divided by Z minus A is A raised to n, right? So let us solve one more example. Let us discuss. So solve by using Z transform. So in place of u, y is mentioned here. Y is they have taken this as a, in place of u notation, y notation we have. So solve this difference equation. So difference equation is y suffix n plus 2 minus 4 y suffix n is equal to 0, given that y0 is 0 and y1 is 2, right? So simple one. Now very first step is take Z transform on both sides. Z transform of this y suffix n plus 2 plus minus 4 Z transform of y suffix n is equal to Z transform of 0. So Z transform of this constant or 0 will be 0, right? Z transform of 0 is 0. So Z transform of y suffix n plus 2 is Z square y of Z minus y0 minus y1 of Z. In place of u, y is given. Only difference is, right, in place of u, y is given. So Z square y of Z minus y0 minus y1 of Z minus 4 y of Z, this is equal to 0. And use the conditions, y0 is 0, y1 is 2. So this is 0, and collect the coefficients of y of Z terms one side. So Z square minus 4 y of Z minus 2Z is equal to 0, because in place of y1 you substitute 2 and Z square is outside. So multiply Z square to this, 1 Z get cancels, 2 divided 2 Z, right, with the negative sign. So Z square minus 4 y of Z minus 2Z is equal to 0. Why? Because we have used the conditions y0 is 0, y1 is 2, right? we want y of z. So for that, z square minus 4y of z is equal to 2z. So y of z is equal to 2z divided by z square minus 4, and take this z to this side. So y of z divided by z, this is equal to 2 divided by z square minus 4. Now consider this one, use partial fractions, using partial fractions. So you resolve this. So consider 2 divided by z square minus 4. Z square minus 4 means how it is like a square minus b square. Z square minus 2 square means a square minus b square. A plus b, a minus b, z plus 2, z minus 2, and numerator 2 will be as it is, right? 2 divided by z square minus 4, this is equivalent to a divided by z minus 2 plus b divided by z plus 2. So 2 is equal to, taking LCM and cancelling the denominator, both sides will get here as 2 is equal to a into z minus 2 is there, multiply z plus 2, plus b into z plus 2 is there, multiply z minus 2. Now by proper substitution of this z, we need to find here a and b. So substitute 2. So 2 is equal to a. 2 plus 2 is 4, and plus b, 2 minus 2 is 0. So I'll get this as 0. So 2 is equal to 4a. A is equal to 2 by 4, or a is equal to 1 by 2. So now substitute z is equal to minus 2. So we'll get here this, substituting z as a minus 2. Minus 2 plus 2 is 0. This term will be 0. 2 is equal to 0 plus b into minus 2 will be minus 4. So b is equal to minus 2 by 4. 2 ones are 2 twos are. So b is equal to minus 1 by 2. Hence y of z divided by z, this is equal to 1 by 2, 1 upon z plus 2 minus 1 by 2 z, sorry, here z I have written, so this should be 1 upon z minus 2. Now take this z to this side. So y of z is equal to 1 by 2 will be common for both the terms. Take it outside. Z divided by z plus 2 minus z divided by z minus 2. Now take inverse z transform on both sides. Z inverse of y of z is equal to 1 by 2 z inverse of z divided by z plus 2 minus z inverse of z divided by z minus 2. So y of n, or yn is equal to 1 upon 2 z inverse of z divided by z plus 2 is minus 2 raised to n, because z inverse of z divided by z plus a will be minus a raised to n. In place of a we have a 2, so minus 2 raised to n, minus z inverse of z divided by z minus a. In place of a we have 2, so 2 raised to n. So this will be the required answer. So these two results we have used. Right. Now let us solve one more example. So last example. So let us discuss this one, and simple one also. Solve by using z transform. Y suffix n plus 1 by 4 y suffix n is equal to 1 by 4 raised to n, and given that n is positive and y naught is equal to 0, it is given, right? And here taking z transform on both sides, and z transform of y suffix n plus 1 plus 1 by 4 z transform of y suffix n is equal to z into 1 by 4 raised to n, right? Now z transform of 1 by 4 raised to n. So z transform of y suffix n plus 1 is z into y of z minus y naught plus 1 by 4. Z transform of y suffix n is y of z. This is equal to z transform of a raised to n, z divided by z minus a. In place of a, 1 by 4, z divided by z minus 1 by 4. Now y naught is 0, and take y of z as a common. So we'll get it here as z plus 1 by 4. Y of z is equal to z divided by z minus 1 by 4. We want y of z. So y of z is equal to z minus 4. Z minus 4. Z divided by z minus 4. Z divided by z minus 1 by 4 into z plus 1 by 4. So y of z divided by z is 1 upon z minus 1 by 4, z plus 1 by 4. So you resolve this by using partial fractions. Now consider 1 upon z minus 1 by 4, z plus 1 by 4. This is equal to a divided by z minus 1 by 4 plus b into z plus 1 by 4. So taking LCM and cancelling the denominator both sides, so we'll get here as 1 is equal to a into z plus 1 by 4, z plus 1 by 4, because z minus 1 by 4 is there, multiply z plus 1 by 4 plus b into z plus 1 by 4 is there, multiply z minus 1 by 4, right? Now proper substitution of z, we need to find here a and b. So let us substitute first 1 by 4. 1 is equal to, because this 1 will be as it is, plus a, this is as it is, 1 by 4 plus 1 by 4 is 2 by 4, 2 1s are 2 2s are 1 by 2, and here substitute 1 by 4 plus 1 by 4 minus 1 by 4 get cancels, 0 into something is 0, so a is equal to 2, because 1 is equal to a by 2 and a is equal to 2. 1 is equal to a by 2. 1 is equal to a by 2 and a is equal to 2. 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 Let us find here b. So put z is equal to minus 1 by 4. So 1 is equal to this minus 1 by 4 plus 1 by 4. So you'll get this as 0. 0 into something is 0 plus b into. So substitute in place of z as a minus 1 by 4. Minus 1 by 4 plus minus 1 by 4 will be minus 2 by 4. So 2 1s are 2 2s are. So we'll get here as 1 is equal to b into minus 1 by 2. Or 1 is equal to minus b by 2 and b is equal to minus 2. So hence y of z divided by z is equal to a is 2, 2 divided by z minus 1 by 4, and b is minus 2, minus 2 divided by z plus 1 by 4. Now we want y of z. So y of z, take this z to this side or multiply z both the terms, taking 2 outside, z divided by z minus 1 by 4 minus z divided by z plus 1 by 4 minus z divided by z plus 1 by 4. So 2 into, now take z inverse on both sides. So z inverse of y of z is equal to 2 into z inverse of z divided by z minus 1 by 4 minus z inverse of z divided by z plus 1 by 4. So in place of a we have 1 by 4. So we have a standard result. What is that? Z inverse of z divided by z minus a is a raised to n. Z inverse of z divided by z plus a is minus a raised to n. So z minus a denominator, in place of a what we have, 1 by 4. So 1 by 4 raised to n. This minus sign is as it is. And here z plus a, in place of a what we have here, 1 by 4. So minus 1 by 4 raised to n. So we have used these two results. Z inverse of z divided by z minus a is equal to a raised to n. Z inverse of z divided by z plus a is equal to minus a raised to n, right? So today we'll stop here only.